Okay, sure. Okay, so today let's do the subnetting of a class B IP address. And IP address I'm taking is 172.25.0.0/16. This is the default IP address which I want to divide, and the required host in a single subnet for us is, let's say, 1100. So I want that in a single subnet there should be at least 1100 IP addresses which can be assigned on the system. Okay. Add it. So I'm taking this table from here. So now we need to just follow through the same process, same steps. First one is our converted host bit. That is H, and the formula for that is 2 raised to the power H, and if we minus 2 from that, it should be greater than 2 host. So this is the formula, and if we see the required host value is -2, this value should be greater than and nearest closest to 1100. So just go through the table, and if you see 1, 2, 3, 4, 5, 1024, 2048.
1024.
So 1024 is smaller.
Yep.
We need to take the next one.
So
that is 2048.
It should be greater than the required host. So we'll take 2000. Yeah.
Correct. Greater than and nearest to the required host. Because if we see greater than multiple values are there, but the nearest value is 2048. Yeah. So take the bit number from there, that is 11. That will be the value of H. Yeah. Next is we need to calculate the second, that is N, and the formula for that is default host bit minus converted host bit. Yeah. So in class B, default host bits are 16 minus converted host bits are 11. So we'll get 5. Value of N is 5. This is total network bits, and the formula for this one was default network bit plus value of N. 16 network bits are there, and if we add
27, yeah,
5,
21.
With this one we can calculate the next value, that is CIDR, and it is nothing but the number of network bit, total network bit with a slash. So slash 21. Then we can calculate the next value, that is subnet mask. And in subnet mask, we need to calculate the binary as well as decimal. For calculating the binary subnet mask, you can check the total network bits or the CIDR. Yep. Check the value in there, that is 21. Just write numeric 1 21 times.
Yeah.
1, 2, 3, 4, 5, 6, 7, 8 dot 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And the remaining bits will be of zeros.
0.
5, 3, 8, 5. Put this into decimal. This binary to decimal. What we'll get?
So it's 255. 255.
Mm-hmm.
And mm, just give me. Yeah, can you help me with that one?
Yeah. Okay, I think should have it. Okay, not this one. You just need to check these last 8 values. And if we just create that block here, six, 7, and 8. Starting from the right hand side, that will be 0 and coming up to 7. And 3, 2, 1, 0. So you just need to put those values here. Like, let me just copy this one.
28.
So just check that value. Like in the first one, we got 255 because of all ones. In the third block, we have 5 ones. From here, 3, 4, 5. And the remaining are of zeros.
It's 128.
Right. 128 plus 64 plus 32. How much it will be? 192. 224.
16.
224 plus 16.
248.
240. And here we have 8. That will be 248.
248.
Okay.
Yep.
So 248, and the last one will be 0.
0.
So this is the subnet mask in decimal for the new network that will be created here. Then next value that we need to calculate is number of subnets, and that was 2 raised to the power n. 2 raised to the power n is 532.
32.
And the last value is block size, or you can say number of IP in single subnet. And that will be 2 raised to the power h, 2 raised to the power 11, and we'll get 2048. So we've got our all the things. Now we need to calculate the range. So for the range, what we can do, you need to calculate 4 things in the range part. First of all, the network address of that network, of that subnetwork. First, usable IP, last usable IP, and broadcast address. So if we calculate all these values for the subnets, how many subnets will be created? 32 subnets.
2.
So the first subnet will always start from the IP which we have here, that is 172.25.00. This time /21. Before it was /16, but the new subnet will have /21. It will start the first usable IP would be 25.0.1. And for now, I'm going to write all the IP addresses here. Let's say 172.25.0.1, 0.2. It can go up to
255.
255. But after that, we cannot take more IP addresses. Like we cannot write 256 here. But there should be 2048 IP addresses. So what should we do next? We should use the next block from there. That will be 1. Okay. So how do we know that in how many blocks we need to change the values? For that, you can check this subnet mask. You can see this one, the block in which the number is not going up to 255. So till after those blocks, the values can change. Those blocks will be of, you can say, host blocks in which the value changes for a network. And another short way to calculate it, like we got the IP address of the first subnet, subnet's first network address, but how do we calculate the network address for the second subnet? Either we write them one by one and calculate them, like add those numbers and see where it will go, or you can use a shortcut. Whatever value you got in the block size, divide it by 256. Get, if we divide 2048 by 256,
Eight.
And what you need to do now, check the subnet mask, check the block in which the value is not going up to 255. Which block is it? The third one. Okay, from the left hand side, if we see, this one is the first block, this one is second, and this one is third block. In the third block, the value is not reaching up to 255. So what you have to do, in the network address of the first subnet, in that specific block where the subnet mask value was not reaching 255, add this 8. Once you do this, what you'll get the network address of the second subnet. If you want to calculate the network address of the third subnet, add this 8 in the third block of the second subnet. you'll get the network address of third subnet. 172.25, 8 plus 8, 16.0. Okay.
Yep.
So you can calculate all these values like this, and as for the broadcast address and the last usable IP,
Yeah.
they can also be calculated by this, because like we see here, the second subnet is starting from 8.0. So just one IP before that, that IP will be the broadcast address of previous subnet. That will be 7.255. Okay. So try doing that. Try writing the, what we say, the subnet mask and the range of all the subnet, all the IP addresses which I've given you.
So you're saying that a range can go because we need required host is 1100, and the range can go up to 2048.
No, a single subnet will go take like 2048 IP addresses. In this single subnet, we will have 2048 IP addresses. Out of that, we will be using 1100. Similarly, the next subnet will also have 2048 IP addresses. This one will also have 2048. So what we had here.
Can you explain me these that you just made as square boxes? That how are we gonna create the next subnet? Where you just can you do that again, please?
Yeah. Just check the block size. If it is above 256, okay. If the value is more than 256, what you need to do, divide that value by 256. And if we divide it by 256, what we got? 8.
Yep, 8.
Correct. So we got 8. Next thing you need to check is the subnet mask, decimal subnet mask, and the block in which your IP or in which your value is not reaching 255.
Yep.
That is the third block. Then you got that the block number is third, and the block size after dividing it by 256, you got 8. So just take this 8, add it into the network address of your subnet in that specific block where the subnet mask was not reaching 255. So that was third block, and if you keep on adding in the next one, you'll get the IP address, network address of the next subnet. Let me tell you a longer way for this. Like once you have calculated these values till this part, till the fourth point, and if you have internet access, in that case we have a subnet calculator which you can directly use, but you need to calculate up to your CIDR value or your subnet mask. So IP subnet, there is a site calculator.net. Here it is. Here you just need to write that IP address 172.25.0.0. It is a class B IP address, and we want to do the subnetting according to what was the CIDR for the new
21.
subnet that we are creating? 21. And then calculate. So first of all, it will show you the network address of the first subnet. The first subnet, broadcast address of first subnet. Okay, total number of hosts it is also showing, usable host it is showing, the subnet mask it is also showing us here. For now, ignore this wildcard. We'll talk about that later. Binary we also got here. If we go down and see here, here it is. So all 32 of the possible 21 possible networks are available. So like we wrote is starting 4, is starting 3. The network address for all these were 00, 80, 16, Next one will be 24, Then 8 will add in that, so 24 plus 8, 32,
So if we keep adding, then we will get all the subnet. If we keep
Right.
adding that,
All the network address of the subnet mask. If we go here and see the network address 00, 80, 16, 24, and so on. It will keep on going up to 248.0. Okay. So you can get help from here once you have done the work manually, because once you do it twice, at least twice on your own, then you will be able to calculate the next one. Okay. Was what we had in subnetting. Okay. So let's start our next topic. So we talked about some network devices, internetworking devices. Which were they?
You mean the physical devices?
Yep.
We talked about router switches,
Switches, routers,
and hubs,
hubs.
and the other one, the other one. Yeah, remember the other one is now.
Repeaters.
Yeah, repeaters, yeah. Repeaters.
And bridge.
And bridges, yeah.
Okay. Other than that, we also have NICs, network interface cards in our systems, which give us network services.
Yep.
And there will be a switch which provides us functioning of a router. That is called multi-layer switch. Okay. So if we go to the Cisco packet tracer, so if we see here at the bottom, on the left hand side, we have multiple devices, and routers only we have multiple models of routers. Okay, so let's just select them one by one, 1, 2, 3. Just like that, we have switches too. And hubs are also there. If you need them, wireless devices are there, cables are available. Then we have end devices, PCs and laptops and servers and all those things. Okay. So now if we want to use them, if we want to access these devices, if we want to connect these devices, if there were only 2 devices, we could have directly connected them using a cable. But let's say I have multiple devices here. So if we are connecting multiple devices, we need a switch to connect them.
Switch all of these ones.
So without a switch, you will not be able to connect multiple devices. So for now, let's just select the first router. So if you click on any router or any switch which are available here, they will show you the diagram of that switch. like how it actually looks. Okay, so it is the back end of that switch. It is in running condition right now. There are some slots available in which you can add some modules here. You just in real case scenario, in real life, you need to purchase these modules. They are just nothing but you can say the interfaces that you will connect there. So these are modular routers in which we can attach extra modules. So if you just take your mouse over the router, it will show you how many interfaces are available. So how many interfaces are there?
Three.
Three interfaces. Out of that, the VLAN one is a logical interface and the other two are physical interfaces. So the first one was fast Ethernet.
The first.
Okay, so in this one, we have fast Ethernet interfaces, two fast Ethernet to be specific. In the next one,
we have
2 gigabit.
2 gigabit Ethernet and one virtual.
And
what's the third one?
That is VLAN, virtual LAN.
So that VLAN one.
Yep. And then next one is there is only a single route, a single fast Ethernet interface. So each model have different configurations, and if you open them, in this one we can attach how many? 1, 2, 3 modules. In the first one, we can only attach 2 modules. So the number of interfaces will depend on the particular device that you are using. Okay. Okay, then if we say the next one is also gigabit. In this one, we have 3 gigabit interfaces already, and other than that, we can attach 4 more. Okay. In this one, we can't attach anything. We can only use which are already available there. This router can be said that this one is a non-modular router, or you can say fixed router, in which you cannot attach any extra modules. Okay. This one also have multiple modules, and the last one is empty. It's up to you which module you want to add there.
So how many types of router are there?
Multiple, depends on the company, you can say. Like if you are purchasing routers of Cisco, these are all the routers of Cisco. They have deployed multiple models depending on the configuration, like some have gigabit interfaces, some have fast Ethernet. What is the difference between all these interfaces? It's the speed of
the bandwidth. Yeah.
Correct. So if it is an Ethernet interface, Ethernet, in that case the speed is 10 Mbps. If it is a fast Ethernet interface, speed is
100 Mbps.
100 Mbps. If it is a gigabit net, speed is 1 Gbps.
1 Gbps.
So depending on which type of connection you are creating there, you will be selecting the different routers. So there is not only a single company like only Cisco. For routers and all these internet networking devices, multiple companies are there.
So
other
the
than
thing is,
Cisco.
yeah, that's what I'm saying. Because I'm only doing a CCNA because it's for I'm only like being familiar with the Cisco devices. And what if the company that I will be working has like they're using the different devices from different company? Then what's gonna happen then?
The commands will be similar. Only the interface will change. Only you can say the way to connect it will change. But once you have connected it, After that, it's similar. Just like if we talk about Linux. In Linux, we have multiple distributions. Like we have Red Hat Linux, we have CentOS, Ubuntu, Kali Linux, and many more. So if we see the graphical user interface of all these in all these distributions, they are different. But once we run the command, almost 90% of the commands are same. So same thing will happen here. The commands, most of the commands are similar. Not everything will be similar, but most of the commands will be similar.
But Cisco is the, if I'm not wrong, Cisco is the most used network infrastructure, right?
Right. So we have Cisco. Other than that, Juniper. One more, Nokia has also creates routers and all these things. Nokia is there. Dex is also there. Okay. D-Link is there. If we go here, if we see here, these are the list of all the devices that are available. Multiple series are available. Let's just open any of these. So these are the routers available with Cisco. If we see the Juniper networking, where they are. Okay. Okay, then next is our switches. If we see the switches here, in this particular switch, the first one, we have 24 fast Ethernet interface. Okay. If we see the second one, here we also have 24 fast Ethernet as well as 2 gigabit. Okay. Then if we go to the next one, it also have the same configuration. In this, we only have how much? 6 fast Ethernet interfaces, nothing more. Okay. This one is empty. If we open it, here we can add some, what we say, some modules which we want to add, so that we can change the working of that particular switch according to us. Okay. This right here is the multi-layer switch which I was talking about. This switch will work as a switch as well as a router. So it provides us multiple functionality. If we purchase router, that will be costlier than this. If we only purchase switch, that will be cheaper than this. So if we want working of both, then this one is better. Okay. Lastly, we have systems, just PC on which we can assign IP addresses, commands, run some commands, all those things. So now we want to connect these devices. On one end, see, we have routers. And I want to connect this router with a switch. Then I have a switch. I want to connect it with a PC. Router directly to a PC. I want to connect two switches. I want to connect to PC. The final is so each will have a different cable configuration while we are connecting them. So in twisted pair only, in STP cables, we can get two types of cables, and those are the first configuration is the second one is crossover. Like, let's see, this is the connector, and the connector have 8 pins in that on both ends. 1, 2, 3, 4, 5, 6, 7, and 8. Five, 6, 7, 8. Okay. So in straight through, what will happen? You will directly be connecting them like this. The first one to the first pin, the second one to the second, and so on. In crossover, the connection will be something like this. The first to the third one, second to the fourth, third to the first, fourth to second, and fifth to seventh, sixth to eighth, and seventh to fifth, and eighth to sixth. So this will be
anyway in crossover.
No, it will be like this. First to third, second to what we say, the fourth, and so on. Okay. So now when we connect them like this, depending on which device we are using, which device we are trying to connect, the cable will change. Let's say, first of all, I want to connect my PC to a switch. In that case, we will use okay. If you want to connect your PC to a router, crossover. If you want to connect your router to a switch, again, copper straight through.
Why is that difference when we connecting different devices?
Depending on the layer on which they are working. If they work on different layers, you need to connect them using copper straight through. If you are trying to connect switch to a switch, you will use crossover. Or if you are trying to connect PC to a PC, they are same devices. We're again gonna use crossover. Except the routers. If you are trying to connect two routers, then we will be using serial cables. And the interface that will be used there to connect these serial cables will also be a serial interface, which you must have seen behind our PCs. We have an interface in which I think how much 666. I think 18 pin slots are there.
Yep.
In which we just tied the screws, and after attaching that cable, we tied the screw so that it stays connected.
Yep.
So those are serial ports and the serial cables. Okay. So you need to take this into account while you are connecting the devices. If you connect them differently, they will not be able to connect. They will not be able to communicate.
Yep.
Like if I use copper straight through cable to connect my PC 0, select fast Ethernet 0 to switch 0. Any port you want. So I'm selecting the first one. Here it is showing green, and on the next end it is showing orange.
Yep.
After some time, that orange will also become green. So mainly there are three modes, you can say. First one is red. Second one is orange. Third one is.
So in crossover, we will be using the same sequence that you have used.
Where?
Like you see that those diagrams, like in the first one, you're just connecting from first to first, and then
No,
not
it's up
this
to
one.
you.
No,
It's up.
not this one.
Okay, just a minute. This one.
Yeah. So you're connecting like you have connected one from first one to first, and then second to second. But in the other diagram, you just so do we need to follow the same sequence what you have used in the second diagram?
Yeah, the sequence will be this, because in straight through we will be just directly connecting the first pin to the first one. We will not be like changing the sequence in the straight through cable. But in case of
Okay.
crossover cable, the sequence will be different.
Yeah.
Okay. And mainly we will not be like designing those cables ourselves. Mostly in most of the cases, you will be just purchasing the cables. You just need to tell them like you need to connect two routers and you need the cable for that. You need to connect two switches and you need cable for that.
Yeah.
Okay, so next will be like three modes will be there. First one is our blocking mode. Which you will not be able to send any kind of data. Your connection is not up in that case. Second one is learning mode. In this mode too, you will not be able to send the data, but it is trying to learn the connection. It is trying to check whether the next endpoint is working or not, whether it should come into forwarding mode or not. The last one is forwarding, or you can say ready to transfer. If we see here, let me just connect another cable from fast Ethernet 0 to let's say 24. So on this end, we got green. On this end, we got orange for now.
Orange.
After some time, it will be changed. We used copper straight through cable. In the next PC, I'm using copper crossover. On both ends, we got red because they are not able to connect because of the different cable.
Yeah.
Okay. So nowadays, some devices comes with extra features, you can say. With that, you will be able to connect these devices with a different cable which they are not supposed to be connected with. But not all the devices, all the routers and switches have that feature. So it is better to remember this, like when you are connecting different devices, you will be using straight through. When you are connecting same devices, you will be using crossover.
Yeah.
Okay, so this one also got green. If you want to delete any cable, we just need to click on that, select this one, cross, and then click on that particular device which you want to delete.
Yeah.
So let's connect these devices first. I'm using copper crossover to connect these two PCs. They are connected. Here, I used a straight through cable to connect same devices. We again got red. If you use different device, a different cable, in that case, it will be up in some time.
Yeah.
And if you want to remove these port numbers that are being displayed here, if you don't want to see them, you can go to options, preferences, and show device. Always show port labels. Just untick that,
Yeah.
and the port labels will be gone. But in that case, it will be a little bit on the tough side to check the ports again and again. So it's up to you whether you want to enable it or not. Okay, then now I want to connect my switch to a router. So we'll again use copper straight cable. But if you see this time, we are not getting any of the connection to be in on state, either in learning state or forwarding state.
Yeah.
Because by default, router shuts down its interfaces. If you want to enable that interface, you need to run the command to enable that specific interface. Only then it will come in a running condition in forwarding state. Otherwise, you will not be able to connect to that router. Okay. So this is the logical diagram which we will be using here to create connections. If you want to see the physical diagram, and if you see here on the left hand side, we have physical workspace. Switch there, double click on the office, and here we have the main wiring closet. Open that. All the routers and switches which we have connected in logical diagram are displayed here. The server is here, routers are here. If you want to connect a cable, if you want to disconnect a cable, that is also possible. If you want to connect it, that too is also possible.
Yeah.
Okay, then next is if we want to configure a router or a switch, what to do in that case. So we want to take access of a switch or a router to manage it. And for doing that, we need a PC or a laptop, and that PC or laptop should be connected to the device in which you want to configure the details. Let's say I want to connect to router 1 and I should be able to access that router 1.
Yeah.
For that, we have a console port on that router. So what you need to do, you need to connect this console cable in your PC in the port RS232, and in the router we have the console cable, console port, just connecting that. Once you have connected it, open your PC. In your PC you need to install some software, like if it is a Windows operating system, you can install Putty or Mobile Xterm or any other software to take access via the terminal. So just open the terminal after that, and then OK. And here you got access of the command line of your router. OK. Cisco IUS software. And if we see here at the bottom, it is saying continue with configuration dialog. If you want to configure it right now, you can say yes or no. So it might be visible, it might not be because of the font is small. Okay.
No, yep, it's visible to me.
So I mainly in real case scenario, we will be accessing the devices like this. We will be configuring them like this. Let me do it right now. Enable configuration terminal, then the interface, and the command for enabling that interface to forwarding mode is no shutdown. So if you see in the back end, that port which was red before is now green, and on the switch end it is orange, and it will come in green in a few seconds. So mainly you will be managing the routers like this or the switches like this. But in our case, while we are doing the practical on Cisco Packet Tracer, we have a feature like you just need to select the router and you have the option to go to CLI directly. So when you click on that, same thing is happening. Same commands are running here. Okay. So we will be working with this CLI in which you, if you want to change the font and everything, you can do that. If you want to change the color of that particular interface, that too is also possible. Okay. Okay, then let's just close it. Same for switches. The switch is a manageable switch. In that case, you will be able to manage it. You will be able to run some commands. You can assign IP addresses and everything.
Yep.
Then next is, let's go here. Let me just put that in access. So what is the functioning of a switch? Why do we use a switch?
To transfer a packet. We can use it to connect some devices, two different devices.
Yeah, two devices of same network.
Yep.
Okay. Devices of same network. It works.
So can we use yep.
Yeah, you were saying.
So can we use like a router instead of a switch?
You can use it, but it is not efficient, because if you see in the router's case, the number of ports are limited. Like the fast Ethernet port and the modules you can attach are also limited. So if you want to connect four or five devices and you purchase a router for that, you can say it is not cost effective, because routers are costlier than switches.
Yep.
So if you purchase a switch for that purpose, it would be better, because in switches mainly for that purpose only, where we want to connect devices of same type, same network. Okay. And what I was showing you here, I'm saying that generally they are used to connect the same devices. If you use this multi-layer switch, you can connect devices of different network too. So it's not like you cannot connect different network devices with the switch only. It is totally possible. But the work will be complex and the work will increase a little bit. But if you use a router for that purpose to connect different devices, in that case, your work is easy and the network load will also be low in your network. Okay. So this switches works with MAC addresses, and they create a MAC address table.
Yep.
In which it will create the table like this: MAC address of the device and the fast Ethernet interface name in which it is connected. Like you must have also, don't know, you must have faced this situation, like if you are connecting a LAN cable in your system, it might work, but if you are connecting the same LAN cable in a different system, then in that system you will not be able to connect to internet. So because in that particular switch they have already configured your MAC address, that only if this MAC address is connecting to this interface, then it should be up. Otherwise, it should not be transferred the data of any type. Okay. Just give me a minute. Okay, 2 minutes. I'll be back in 2 minutes. Okay. Hello. Hello.
Yep, yep, yep.
Okay, so yeah, so the device, the switch will create a table and maintain that table so that the connection, that data we send in the network will be sent
Yep.
a little bit easier without any collision or without any extra traffic in the network.
Yep.
Okay, so multiple types of switches are available to us. First one, we have our fixed switches. Second one, we have modular switches. Okay, so in fixed switches, we have fixed number of interfaces. The interfaces cannot be changed, or you can say the hardware cannot be upgraded. Okay, whereas in modular switches, the number of interfaces can be added if we want, and it will be, you can say, a little bit costlier than the fixed switches. Like if we see here, this first one is a fixed switch or modular switch. Hmm.
That's modular.
Nope, it is fixed because in this one you cannot add some extra devices, extra ports. They are limited. If we select this one, this will be a modular switch because you have some modules that you can attach here. You have slots in which you can attach modules. Okay. And sometimes you might get switches like this. Just a sec. Like a box like container will be there, and in that multiple switches will be attached, fixed switches or modular, it's up to us. So if we see it as a whole, this outside block, this will be called a modular switch, because in this switch we can attach and detach some ports, some interfaces. If I only attach three switches here inside that, the number of interfaces I have is limited. Okay, is less. But if I attach four, the number of interfaces are more. So we can change the interfaces here. We can upgrade or degrade our hardware. So those will be modular, and in fixed switches, you cannot attach extra interface and all those things. Okay. So other than these, we can again divide our switches into three categories depending on the hardware capability. First one is access layer. Then we have distribution layer. Distribution is and each layer have multiple, you can say, models which are available for that specific layer. So if we are using connection, if we are creating connection for small organizations, we will be using switches which are available in our access layers. Like we have, if you want to connect your company's environment, in that case, you can use these switches. If you go outside of your company environment, if you want to connect medium level organizations, or if you want to connect ISPs which are available throughout the country, in that case the switches will be used, will have some extra functionality. They will be modular switches in that, like which model it was, 6000 model, 6000 range is there, 5000 is there. Okay. And these fixed switches will be used. In this one, we can use the modular switches. In this one too, we will also use the modular switches, but it is mainly used for country-wise or nationwide or global-wise coverage. So in the core layer, the devices will have high functionality. The speed of those devices will be faster. The data transfer rate will be faster. Mainly they will be used in medium level.
Yeah, we use S because you're using Z. That's the US one.
I always get confused with this one.
No, that's all right. No, that's all right because in the US they use the Z because in Australia we use S. But I always use Z.
I sometimes use Z, I sometimes use S. So every time I write it, like I'm like, what should I write this time?
Yeah, because it's different in every country. So I use.
Okay, so access layer will be small organizations, data speed will be low.
Yep.
Data transfer speed will be low. In these cases, data transfer speed will be medium and high. Let me write that one too. Medium and high. Okay. Then next are interfaces. So we already talked about interfaces like fast Ethernet is there, gigabit is there, Ethernet is there, and in new devices you might also get the 10 gigabit interface too. Okay. Other than that, we have some interfaces, some ports which are available. Like fast Ethernet port will be displayed like this: FA00, FA01, FA02, and so on. It is a gigabit. It is gigabit Ethernet. GI, I think 00, 01, and so on. Another one is console port to connect the console cable. It will be generally console 0. Other than that, we have the last one, and those are called logical ports, or you can say logical lines. And they will be PTY 0 to 15. Okay, so they will be used for later on when we will try to connect the switch using telnet connection. In that case, we will be using these logical ports. Okay. So let's go to Cisco Packet Tracer again. I'm cleaning everything here. Select all, delete. Yes. I'm connecting 1, 2, 3. 3 devices, 3 PCs with a switch. The cable that will be used is copper straight through. And while selecting the cable, if you press Control and then select it, so then you only need to select it once. Now you can use it multiple times, like fast Ethernet 0 to 0, 1. Now again, without going to the cable, selecting the cable, we can directly use it. Otherwise, what would have happened? Like, let me remove it again. If you have just selected it without pressing Control,
Yep.
after using it once, it will be gone. You need to select it again. Okay.
Yep.
So let's wait for it to connect. And I'm accessing the CLI mode of this switch. So if we see here, this switch started and there it was going under the booting process of that particular switch, or you can say the booting sequence of that switch.
Yep.
Okay, so just like Windows, Linux, or any other operating system, these switches and devices also have an operating system that is called iOS, Internet Network Operating System. Okay, here it is. So this iOS also needs to be loaded. Only then you can access the commands. Only then you can see the commands here. So it goes through multiple memories. It loads the image, and then your system starts. Like if I go to, if I'm deleting this switch here and connect a different switch and go to its CLI mode quickly. So see here, it is going through the booting process, booting sequence,
Yep.
and then it is started. After when we connect the cable, logs will be generated and we can see them on the screen. Like I connected the first one. Here we got interface fast Ethernet 01. Changed state to up.
Yep.
These, let's connect it in 2 only, and that 3. So we connected these interfaces one by one. So if we talk about the booting sequence of a switch or a router, the booting sequence will be similar for both of these. First of all, they will perform an operation that is called host. And what it is? Power on, self. It is just the just do the checkup of the hardware, whether the RAM, the CPU, and the interfaces are working or not. And you must have noticed in the PCs too, in your personal computer, when you start it, when you just on the power button, in that case, first of all, it sends the power to all the devices and the light will blink in every device. If it is a keyboard, in keyboard, the light will blink and then off. In mouse too, in CPU too, in monitor too. After that, your system starts. So in general systems too, it do this power on self test to check whether the hardware is in working condition or not. So first step is hardware check. Okay. The second one is our ROM. It is a read-only memory. Which finds the location of the complete iOS, where the complete iOS is available. Okay. So first step was host, second was our ROM, third one is our flash. Another type of memory which stores the complete iOS image. Okay. The complete iOS image will be there, and it may have multiple iOS images.
So this iOS image is the operating system?
Yep, operating system of the router or the switch.
Of the switch.
Okay. And like if we see here, it generally is like this. This is the complete iOS. Okay, it is available in Flash. The name is C92950 something. Okay. After that, next step is NVRAM. That is a non-volatile random access memory. Volatile random access. And what it does, it stores the permanent configuration of the device. Permanent Okay, and generally the file name for that configuration is startup-config. So whenever we are starting a switch, whenever we are starting a router, it will always starts with the startup configuration. Okay, so what it does, it takes the startup configuration from here and then copy this startup configuration in the next memory, that is RAM. Random access RAM. So what it stores the temporary configuration. That temporary configuration file name is running config. Okay. So it will, whenever we are starting a switch or a router, it will always do these 5 steps. It will take the startup config and then copy that startup config to running config and then start the system. And if we want, after working on that particular system, after working on that switch or router, if we want to save the changes, we need to do the opposite thing. We need to copy running config to startup config. So that next time when it uses the startup config, the changes will be there. Okay. So this is the boot sequence we have. And let me just first. And let's go to the device. Let's assign IP addresses in these devices. So I'm using the IP address N001/8 N002/8 N003/8. So I want to assign these IP addresses on these systems. Just select it, go to desktop, IP configuration, and N001. Same for the next one. Same for the third one. And 0, 0, 3. Okay. If you want to check connectivity between them, you need to run the command ping, and using ping command you can check the connectivity. So when we are using the ping command, what it is doing, it is sending a hello packet to all the devices, and if it replies, that means we are able to connect it. So if you want to send a packet, here on the right hand side we have these packets. So we can select that packet and send it from source to destination, but currently it is selected in real time. So just above this real time icon we have the simulation option. So select that one, then select your packet, select the source. I want to send the data from 10.01 to 10.03.
Yep.
So if you see here, there are 2 packets which were generated.
Yep.
Okay. And if we see here, we have the capture option or the forward option. It will take it one step ahead. So I'm just clicking it once. First of all, the green packet went to the switch.
Yep.
If you again select capture, it went to all the devices which were available in the network.
Yep.
But see here, and this one. So on both devices, one was failed and the other one was delivered successfully.
Yep.
And the one on which you can say it is showing us failed, it will not reply us anything. Only the device
So
which,
why it's failed?
because it was not the address on which we wanted to send the data. Okay. So first of all, it is generating that particular address. It is using a protocol here, address resolution protocol. So via that, it is maintaining, it is generating a table, creating a table, and then it will send the data from then on. And now that ARP was successful. Now the actual ICMP packet, when we ping will be sent. So if we capture forward now, it will directly go to 10.03. And you will receive the reply that the ping was successful. If you click on this packet, you can also check the address, the layers, on which layer what is happening. So here we have the source address, destination address, the port numbers, and everything. Okay. And finally, the data was delivered. Data was received back on our system. Let me delete this packet. I'm generating another one from PC5, the 10.01 IP address to 10.03. This time only one packet was generated. If you capture forward, it will first go to the switch. Then from the switch, it will go to directly to that PC. Then again to switch, and we'll get the reply. So why didn't it go to all the devices again? Because it already have generated, it already have created an entry for 10.03 and 10.01. If I send the data from 10.01 to 10.02, so we are sending the data for the first time on 10.02 device. That's why it generated again two packets.
Yeah.
Okay. And if we just select auto capture, it will keep on working on its own. So switch will do broadcasting for the first time. After that, it will do the unicasting. Okay. And let me just connect 3 more PCs. 1, 2, 3. I'm providing the IP 10.0.5, 6.0.7.
So it's not broadcasting. I mean, it's a unicasting because it's sending a separate data to each computer.
Yeah, only the first time it was doing the broadcasting. After that, it is just doing the unicasting, the switch. Okay. Let's delete this one for now. Next is I'm gonna assign IP addresses on these devices. 10.0.0.5. 10. 10.0.0.7. And instead of a switch, I'm using a hub. So if you see, only 6 ports are there, and as soon as you are connecting that, it is in forwarding mode. Okay. So if we send the data from PC8 to PC10, capture forward. First it got to the hub. Hub will send to all the devices. Then back. Again it will send to all the devices. Okay.
Yep.
Now if I send it next, again to all the devices. So hub is doing broadcasting in every case. Whenever it is receiving some data, it will pass that data to everyone. If that data is reach the destination, that's fine. If it doesn't, it will be discarded. But still the data is reaching to that source, to that particular system. If you want to capture it, you can do that. So from the security point of view, this was a drawback in hub. That's why it was stopped using. Okay. So let me just delete these. Instead of deleting them, I'm going to connect these devices to my switch. So 6 devices are connected, and you can check the connectivity in all of them just by running a command like ping on 10.0.0.2. If you are getting the reply, that means you are able to connect. If you do ping 10.0.0.3, there too we are going ping 10.0.0.5. You got the connection. At 10.0.0.7 also there. 10.0.0.8 is not there. So we'll get an error. Request timed out. Okay. To break this process, Control C. So like this, we can connect these devices and check the connectivity. Now let's get back to the switch. So right now, if we see here in the switch, we can run some commands. What commands we can run? Just put a question mark here. You can use here. Okay. First of all, this one is our user mode. So again, we have multiple modes in the switch and the routers where we can run the commands. And depending on which mode you are working, the commands will be different. The level of access in that device will be different. So first is user mode, in which you will get, so first of all, the host name of the device, and then this greater than symbol like we are having here. So we can only run limited commands. If I want to gain some more access, in that case we need to go to the privileged mode. And for going to the privilege mode or turning that privilege mode on, you need to run the command enable.
Yep.
Either run the full command enable and then press enter. It will take you to the privilege, or what you can use en and then press tab. So tab completion is there in the devices, so it will, if it found the match, it will complete it. If you only write E and then press tab, nothing will happen. But if you write E and then question mark, it will show you all the commands which are starting from E. If you write En and then tab, it will complete that command. Or even if you don't press tab and just write enter, press enter, it will look for that specific command which it found the match for and then run that command automatically. So now we are in the privilege mode. One is privileged mode, in which the symbol will be hash. Third is global configuration mode, in which it will be like this. The host name of the device, then config, and finally the hash symbol. Okay. If you are configuring a particular interface, that will be called interface configuration mode, and that it will be if config. You need to remember the starting three: user mode, privilege mode, and global configuration mode. After that, whenever you are configuring anything, it will have a different configuration mode of its own. Let's go here.
Yep.
If we press question mark again, so these are the commands that we can run in the privilege mode.
Yep.
I think from clear, and it is still going on. Now we want to go to configuration mode. For going to configuration mode, we need to use this command. Here it is. Enter configuration mode, and the command is configure, and we need to open the terminal for that. So configure space terminal. So if you write configure, just press enter. It will ask you configure what? Configure terminal, enter. Or in configuration mode. And press question mark again, it will show you all the commands that can be used in the configuration mode now. Like if I want to change the host name of my system, so the command is host name and whatever host name I want to set. Let's say India. So if you see, the host name has been changed. Okay. And if you want to set password on this particular device, okay, for that you also need to go to the configuration mode, only then you can set the password. So for now I'm closing this switch.
We can set password through configuration, right?
Right. Okay, so let's take 5-minute break, then we'll start.
So
Yes.
So what time we will finish in?
We'll finish by 4, like 1 hour from now. Or do you want to continue later?
Yeah, I thought because we started at 5 or 5:30.
Mm,
I mean, we
like
started at 1 or 1:30. I don't remember. What time we
around
started?
1:15 I think we started. Yeah, 1:15.
Okay.
So do you want to continue if you have time?
Yeah, I mean, we can do 2 hours. I mean, like 15 minutes more because we obviously 15-20 minutes because we started at 5:15,
Mhm.
and then we can continue from Monday.
Okay,
That's
sure.
all right.
Just give me 1 minute. I'll be back in 1 minute. Then we can continue.
Yeah. Okay.
Okay. Hello.
Yep.
Yep. Okay. Let's start. Ouch. So I'm taking a switch here. Sorry,
Yep.
a router, and I want to access this router. So if we see here, the router is starting. The booting process is going on,
Yep.
and it is started. So for now, what you need to do, you need to write no. You don't want to configure it right now. You just say no and start the router. Which mode is it? The first one in which the greater than sign is the greater than symbol is there. This one is user mode.
Yep.
If you want to go to privilege mode, the command is enable.
Enable.
Once you are in that, and now you want to go to what we say, the configuration mode, you can use configure terminal. But before going on that part, if you want to check the version of your system, if you the router, you can use show command, show space version, or if you just write show space question mark, it will tell you all the things that you can display here. Okay. You want to see the version, so show version. It will show you the version of your particular router. Okay. The system image file is this one. If you press enter, then you can see the configuration register value. For now, it is showing us the register value 0x2102. In that, what it does, it loads the IOS from flash with default configuration. So the default configuration which are available in our NVRAM. Okay, so the IOS will be loaded from the flash memory and the configuration will be loaded from the NVRAM. Another configuration register value is available to us that we will be using while we do the troubleshooting part. And that configuration register value is 0x2142. So how to change the configuration value and everything we will see later on. For now, it was there, so just I was explaining it. Next is if you want to check the interfaces that are available, you can also do the show interfaces. So it will display all the interfaces which are there. Then we have show IP interface, showing you that it is administratively down. If you want to show it in brief, in that case, it will only show you the interfaces, the IP address that is assigned. Okay. If you do show running config is the current configuration what you are doing right now, which is available in your random access memory in your RAM. Here it is showing you the host name is router and the details which will be available. If you do show startup config, this is the configuration that will be read on the next boot. So for now it is saying startup config is not present. It is using the default configuration of the router when it is a fresh device, when there is nothing we have added in the device. Okay. So for now, let's go to configuration terminal using command configure terminal. And I want to change the host name. So the command for that is host name. And whatever the host name you want to set. Exit from here, you'll be going back to the privilege mode. And if you want to restart your router, you can run the command reload. If you just run reload, press enter. It is asking you whether you want to proceed. For confirmation, just press enter. And your router will start again. So let's wait for it. If we do no, enter, the host name is back to router. Why is that? We changed the host name, right?
Yeah, we changed the host name because we reloaded the system again, so that's why.
Not exactly. Let's say I have a notepad file here. If I write the content, any content, and close it without saving it, don't save. Can I get that content back? If I open another notepad,
No,
you cannot, because that content is gone.
So we need to save it.
Correct. So we need to save the changes. So On the next boot, we can get the changes.
Yeah.
The host name again, first of all, enable configure terminal
and config terminal
and host name India.
then save.
For saving, we can use two options. In saving, what actually is happening? It is just, where is it? Here it is. This one. It is just copying the running config data to startup config file. So it will copy the data of running config to startup config. So we can do this by two options, two commands. First command is that we can use copy space running config space startup. So if we do this, the configuration will be saved. It is asking destination file this, press enter, building configuration, okay. And even if you reload your system now, the configuration will not be reset. It will be the same which was at the time of reload. Host name is still India. Okay. And next is I want to set the password here. On the router, I want to set the password so that when we do enable, it should not go directly to the privilege mode. It should ask us for the password. So for setting the password, we need to go to again terminal configuration terminal. Here for enabling the password, command is enable password and whatever password you want to set. So I'm setting 123. Exit from here, or if we exit, it will just go back one step. If you directly want to go to your privilege mode from any configuration mode, you can directly press Ctrl Z. It will take you to the privilege mode. And if we see show running config, here it is showing that enable password is set to 123. If we run show startup config, so the startup config and running config are different for now. So we need to do what? Copy running config to startup config. So either use that same command, copy space running config space startup config, or you can directly use this command. Right. Just write and then press enter. It will build the configuration, and if you see show startup config, the password is there. So the right command is doing the same work as copy running config startup config. Okay. Let's reload the device again. Device is started, and if we do enable, enter, it is asking us for password. Okay. If we
already set the password. I mean, so then once we set the password, the next time when we enable, so we'll ask for password.
Yes. Next time it will ask for password. If we give the password wrong, let's say 789, anything, secrets. If you give the password correct, you'll be able to log in. Okay. And let's say I started my router, I connected it, and I went for some work. and you were sitting there, you also knew the command of the router or the switches. So you just ran a single command, show setup, and the password is there in raw format. Correct?
Yeah.
You can see the password. So if you want to encrypt the password, in that case, we have two types of encryption which we can use here.
And the other thing is, so why we need a password for the router? Are you?
Why we need the password for the router? If the password is not there and if someone else tries to connect it, he can directly connect it and he can do anything he wants on that particular router. He can change the configuration. He can just remove your configuration, remove everything from the device.
Yeah.
Okay. So anybody can attack it. If password is there, you have a security layer. It can only be cracked if the person who is trying to access it knows how to break the password. Otherwise, he will not be able to break it.
If
Okay.
it's encrypted, then we won't be able to do it.
Yeah, if it's encrypted, in that case, you won't be able to break it easily. Like two types of encryptions are also available, type 7 and type 5. The commands for both of these are different. For type 7, after setting the password, after running this command, enable password, and the password that you were setting, let's say 123, you need to run the command that will enable the encryption service, and that is service password encryption. As for type 5, you will directly run the command enable secret and then whatever password you want to set. Let's try to do the both. First of all, I'm doing the type 7, and if we see here what it is saying, service password encryption as no. So right now it is disabled. If you want to enable it, go to configuration terminal and run command service encryption. Enter. If you see show running config, your password have been encrypted. Okay.
Yeah.
But it is as good as like you were writing 123 and you just wrote it as 321. But if you just go to browser and do type 7 decrypt, open this, and just paste your value here, submit. You got your password. Okay.
Yeah.
So the type 7 password is there, but the encryption is there, but it is as good as it's not there. Okay.
Yeah.
The other one is type 5. In that case, the password will be encrypted with the higher level of encryption.
Yeah.
So for that, first of all, let's remove the password. So how do we remove the password? Go to configuration terminal again.
Yeah.
To set the password, the command was enable password, correct?
Yeah.
Just write no in front of that.
Yeah.
So if you write no enable password, enter, and also no service password encryption, enter. Exit from here. And if you see show running config, the password is removed.
Yeah.
Now we want to set the type private password. Okay.
Yep.
To set the password, that password, the command is enable it. First go to configuration terminal, then enable secret, and I'm writing, let's say 456, enter. If you check the password, show running config, here it is. So it generates, it uses a random value which is generated on the system and then encrypt your password. And it is using the MD5 algorithm for that. So your actual password is here.
Yep.
Which is the encrypted password. So even if you try to copy this, paste it on the type. So it is starting, it is brute forcing that it might be possible that it may break, and that is very, very, very rare chances for that.
It's very bad if they if it can break the 5 one as well. That's the toughest one.
Right. Because what it does, it uses a random algorithm, random value. So
Yeah.
even that value,
But then
even
it's
after
not
getting that value,
possible. Yeah.
yes. So it is a, you can say, in very rare chances it might break, but it will be the most, you can say, secure method to set the password. After setting the password, you of course you need to run the command write. And this write command can only be run on the privilege mode. If you try to run this write
And
command,
why we do this write command?
to copy the content of running config to startup config, to saving the configuration.
Yeah. Okay.
If you try to write, if you try to use that command in configuration mode, what it is saying, invalid input. So if you have a situation where you can't go back to the privilege mode, you need to run a command which was used on privilege mode in your current mode. For that, you can use do. If you write, like if you do this, so do write and press enter, this time the command will run. So if you want to run a command of privilege mode somewhere else, you need to use do. Okay. And if we just like do reload, the next time system will start, the password will be there, and without password, you will not be able to access it. Enable password is there, 456, and it will open. Okay.
Yep.
So what you need to do is take a switch and set the password on the switches. So try doing it, because in Cisco as well as in Linux, the more command you run, the more you remember them.
Yep.
Okay.
Can we check the password if it's cracked or not?
Yeah, sure. I think it's stuck. The rare case which I was telling you, like the password may break, will only happen when, by some coincidence, this random value matches the one which they already have in their database. So this random value as well as this value, if they matches and they already have a record for that, only then they will show you that the password is this. And you can say there is a 1 in a million chance for that. Even the Red Hat, the Linux, they also use this encryption mode to set the password. So try running the commands, try checking these
Yeah.
commands we have discussed.
Yeah.
And in the next session, we will see what VLANs are, virtual LAN, what it is, and how can we play with virtual LAN so that we can create multiple departments under the same network.
Yep.
Okay. Let's save this first. And we didn't change anything in that. Let me send it. Okay, so let's continue tomorrow.
Yep.
Same time.
Yep. Yep.
Uh,
Yeah, we can continue tomorrow. Same thing.
yeah.
All right.
Okay. Have a
No
nice day.
worries. Thank you so much. You too.
Welcome.